Python programming, session 2, Python basics. The agenda of the session is variables in Python, assigning values to variables, statements in Python, standard data types like numbers, strings, list, tuples, dictionary, all these variables we'll understand, and data type conversions, changing from one data type to another. Yeah, this Python is, I think, first programming language we are doing officially, right? Any programming language is made up of few things, building blocks. The first is the character set. What all characters are recognized are part of that programming language. Any programming language is made up of some few characters. Second is the keywords, which are recognized by language. Third is grammatical rules. Fourth is operators and operations. These are building blocks of any programming language. Without variables, we can't think of a programming language. Variables basically are placeholders in memory. If you reserve some memory area, give it a name, and that is called variable. Not only this, in fact, very strangely, you will never ever find the right definition anywhere, because the characteristics of variables are: one, they are categorized by their size, how many bytes it will be using, 2 bytes, 3 bytes, 4 bytes, or what. Second, they are in memory, they are not on the disk. Third, they have some specific address. And fourth, they are not permanent. You restart your computer and they are gone. The complete definition you will see today. You will not find the definition anywhere. So what are the variables in Python? How to assign values to variables? What are the statements in Python? How we create statements? Standard data types, numbers, strings, all these things you will understand in this lecture. A lot of examples will be used. Examples are already created, screenshots are taken, so I'm going to demonstrate those programs as well. Variables. This is the complete definition. Variable is a named location in the memory of computer characterized by a data type whose content can change. Now each word is important. Named location in the memory. They are not on the disk. They are in memory, RAM. They have to have a name in the memory. Characterized by data type. They must have a data type. We can't think of a variable without a data type. And whose contents can change. They are not fixed. Their content can change. So by definition, this is a variable. This is how you define variables. Variables are nothing but reserved memory locations to store values temporarily. For example, if I ask you subtract the sum of 2 and 3 from the sum of 5 and 4, what you will do? You will add 2 and 3, which comes out to be 5. You will keep it aside, you will remember it. Then you add 5 and 4, which makes it 9. Then you recollect what the previous value was. So that temporary hold of the value, that's a use case of variables. We use variables for that purpose only. So when you create a variable, you reserve some space in memory. Based on the data type of a variable, the interpreter allocate memory. Means they are characterized by a data type. Remember that, very important. And decides what can be stored in the reserved memory. By assigning different data types to variables, you can store integers, decimals, characters in these variables. So therefore, when you create variable, what kind of value is stored or what kind of data type it is, they are all related terms. The data types and the value stored in the variable or the type of the variable. How do we assign values to variables? Python variable do not have to be explicitly declared to reserve memory space, unlike other languages like in C, in Java, in .NET. All other languages require the variable to be declared first before being used. COBOL, Pascal. I can talk about multiple languages where the variable need to be declared first before being used. But Python variables, we do not have to explicitly declare. But yes, what value you are assigning, Python will judge the value stored. Judge the data type of the variable based on what value you are assigning to it. The declaration happens automatically when you assign a value to a variable for the first time. So you don't have to, unlike other languages, as I said. A simple assignment operator, that is equal sign, is used to assign value to variable explicitly. The operand to the left of the equal operator is the name of the variable, and operand on the right hand side of the operator is the value stored in the variable. Let's take an example. This is stored in session 2 directory with the name python1.py. So first line is shebang, as I explained in the previous lecture, lecture 1. User bin python 3. This is the interpreter I'm going to use for this program. Counter equals 100. This is example of assigning integer value to a variable, and it is assigning value 100 to the variable counter. We have not declared it, so it is declared at the time of this assignment itself. So it means the counter will be an integer value, the integer type of variable, because we are assigning value 100 to it. If we take another variable, let's say miles equals 100.0, this 0.0 will make it floating point, the decimal point. So this is going to be floating point variable miles. Similarly, name equals John is going to be a string, because we are assigning a string value to it. So strings are enclosed in double quotes. So we are printing all these values. Print counter will print the value of counter. Print miles, it will print the value of mile. Print name, it will print name. Let's look at the example. Output of this program is as given in this. When I run this program, Python 3, python1.py, this is how we run the program. When I run this program, you will get first value 100, that is this one. Second value 1000, that is this, because of this statement, print statement. And third is John, because I'm printing name. So I get the value John. All these three values are displayed one by one, and that's the output. Let me show you. So this is my system where my programs are available. Python, I have to go to session 02. Every session has a corresponding directory. I'm going to share all these codes after every session with you. So first, let's look at the first program, cat python 01, python1.py, and this was the example. Counter equal to 100, miles equal to 1000, name equal to John, print counter, miles and name. Printing all those values, same program. And to run it, I type python 3 followed by python1.py, and the same output what was displayed. Similarly, let's look at the second program also, which will come eventually, definitely, cat python2.py. So this is second program. Next is going to come string value. I'm going to store value hello world in the string. Now when you say print str, it will print the complete string. When you type str0, means index number 0, so first character will be printed, that is h. So you can expect first character of the string. Now string 2:5 means character number 3 to 5th, because counter starts from 0. So the third, fourth and fifth, third to 5th characters will be displayed. And then 2: means third character onward, entire string, because you are not giving the end point, the last character, you are not specifying, you are not giving the last value. So entire string from third character onward will be printed. String multiplied by 2, the entire string will be printed twice, 2 times. And string plus test, so it will display hello world plus text test. That means together 2 strings will be concatenated. Let's run this program and see the output, and then I'll explain. So first, entire string. Second, character number 0. Third, fourth and fifth character LLO. LL started onward till the end. Hello world twice. Hello world followed by test. So all these are examples on strings. That's how string works. So, and then let's try third program also. Then I'll explain together. First, let's see the cat output of what the program is. So the program is list. It contains multiple elements. Put in square bracket. ABCD 786 2.23 John 7.70.2, and then this is tiny list 123 John. Now print list will print the entire list items, means from here to here all items will be printed. List 0, the first element of the list, that is ABCD, will be printed, first element. List 1, 3, element number third, fourth, because 1 to 3 starting from second, 1 means 2, so second to third. Then 2 onward, that means third onward, because counting is starting from 0. And tiny list multiplied by 2, the entire list will be printed twice. Compare the output which I have done. The first list printed twice completely, the first element printed, then element number second till third, that is printed, second and third. So that is second is 786, third is 2.23, and then next is all these elements are printed, that is third element till end, starting from third we are giving 2 onward. So all the elements from third are printed, that is a third element in the list is 2.23. So 2.23 till the end all elements are printed. Then print last the entire list twice, that is the entire list printed twice here. Alright, so that's how it works. This is how the list works. Tiny list plus tiny list means both the elements, the elements of both lists are printed here. So basically this is how the list works. So first part was Python 1, we understood that, the output also clear. Second is multiple assignment. We can assign multiple variables simultaneously. Python allows you to assign a single value to several variables simultaneously. For example, this value 1 is assigned to A, B and C, all the 3 variables. This is allowed in Python. Not every language allows this, remember. You can't do this in every language. It is actually a best of all languages, let me put it that way. Here an integer object is created with value of 1, and all 3 variables are assigned to the same memory location. That means the same memory area is referred by the variable A, B and C. You can also assign multiple objects to different values or multiple values. Little carefully we observe this. Look at here, A, B and C equals 15, 20.57 and sang1. So A will have value 15, B will have value 20.57 and C will have value sang1. So here one integer object A with value 15, second integer variable B with value 20.57 and third string object C with value sang1 is assigned. So you can assign multiple values to multiple variables in a single line. Python allows that. Statements in Python. How do we write statements in Python? Statements in Python end with a new line. That means the moment you press enter key, a new line is created, the new statement starts. Python allows the use of line continuation character. Now this is the characteristics of shell, if you recollect. In shell we can have multiple command spread across multiple lines if we put slash at the end of the line. Python allows the use of line continuation character, which is also used in shell programming or Linux, to denote that the line should continue. For example, total equal to item 1 plus item 2 plus item 3. This actually make it more readable. So you are using item 1 plus item 2 plus item 3, and this slash is actually allowing you to continue. But remember, there should be no extra space after slash. This should be the last character in the line. Statements contained within square bracket, curly bracket or parenthesis do not need to use the line continuation character, which means when you are putting multiple elements in the list, for example, this is a list, Monday, Tuesday, Wednesday, Thursday, Friday, you can continue the line without using line continuation character, because you are starting the string here, you are starting the list with square bracket, so it must be closed with square bracket, so you can continue in the multiple lines. Multiple statements group as suite. That's also allowed in Python, that you can group multiple statements, and that is called suites. Group of individual statements which make a single code block are called suites in Python. The compound or complex statement such as if, while, def and class, which actually require a block, we call them as suites in Python. Like when you start if statement or while loop or def statement or class, we put multiple lines together, that is called suite in Python, which require a header line and a suite. The header line begins with statement with a keyword and terminate with a colon, and are followed by one or more lines which make the entire suite. That means colon is the marker here. Colon is used to start that yes, I'm starting a suite here. Standard data types in Python. The data stored in memory can be of many types. Python have 5 standard data types: numbers, strings, lists, tuple, and dictionary. We need to understand all of them one by one with examples. Python numbers. What are numbers in Python? The number data type store numeric values. They are immutable data types. Immutable means you cannot change, you can replace. Changing the value of a number data type results in a newly allocated object. That means you override them. You cannot change the value. They are immutable data types. Number objects are created when you assign value to them. For example, var1 equals 1. So variable 1 is created and you are assigning value 1 to it. var2 equals 100. That means variable 2 is created and value 10 is assigned to this. Look at these examples. You can also delete the reference to a number object by using del statement. We'll look at the examples now. Del var1, var2, var3. This is how you delete the numbers. You can delete a single object or multiple objects like del var1, var2, or var a, var b. Python supports 4 different numerical types: long, float, complex, and integer. Integer means signed integers. Long means long integer, can also be represented in octal or hexadecimal format. Now what are octal and what are hexadecimal, I would like to explain because you are not from IT background, so you need to understand it. 0 and 1 is called binary number system, which uses only 2 digits. 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. This is octal number system, which uses 8 bits. 8 digits or 8 bits, or 8 digit, right word, 8 digits. So that is called octal number system. Hexadecimal number system uses 0 to 9, that is 10 digits, plus A to F. So 16 total digits it uses. The relationship is very interesting to find out between these number systems. When you say binary, it uses only 2 digits. And these numbers, octal number, when I say 0 to 7, 0, 1, 2, 3, 4, 5, 6 and 7, these values can be represented by 2 raised to power 3, because 2 raised to power 3 comes out to be 8, and 2 means the base, which uses only 2 digits. So if I use 3 bit at a time, out of these 2 bits which are there with me, 0 and 1, I will have all the digits equal to corresponding binary number. For example, 0 will be 300000. And now simple way to produce the entire string: 0 1 0 1 0 1 0 1. Keep on repeating. Second digit you replace alternatively. After 2 digits, replace it 1, right? 0 0 1 1 0 0 1 1. And third you replace after, repeat after 3, so 3 times: 1 1 1 0 0 and so on. So 0 0 0 is 0, 0 0 1 is 1, 0 1 0 is 2, 1 1 1 is 3, 1 0 0 is 4, 1 0 1 is 5, and then okay, sorry, third time. This was to be given here. It has to have been 4 times. Right, I can write straight away 0 0 1, because I know 0 0 1 0 0 1 0 1 0 0 1 1 0 1 0 0 1 0 1 1 1 0 1 1 1. These are 8 possible digits. So, and formula, if you want to calculate mathematically, come out with the digits, you keep on dividing the number by 2 and you'll get the answer. Like if I divide 8 by 2, keep on noting down the, keep on taking the note of remainder. So 2 4 ja 8. So what is remainder? 0. So we keep on dividing by this, keep on, take note of the remainder every time. So if you keep on dividing by 8 with this formula which we do normally, like 8 divided by 2, so 2 4 ja 8, remainder 0. Again 2 2 ja 4, remainder 0. Again 2 1 ja 2, remainder 0. Again 2 0 ja 0 and remainder 1. So this 1 triple 0 will make 4. Similarly, we can find out with 7 also. That's how you convert binary to octal, and exactly same way we convert to hexadecimal. Hexadecimal will need 4 digits, 4 binary digits: 0 0 0 4 times, 0 0 0 1 and so on and so forth. So that is hexadecimal number and octal number. The long can also be represented in octal number system and hexadecimal number system. Float is a decimal, that is floating point real values. Complex is iota and all that imaginary values, complex numbers, which you have studied in your mathematics in your school days. Now this is examples of Python numbers. Python allows you to use a lowercase l with long. Python display long integers with an uppercase L. The complex number consists of an ordered pair of real floating point numbers denoted by a plus sign bj, where a is the real part and b is the imaginary part of the complex number. Now these are examples. This is integer, and long, this is long value. So like you are using L to prefix. Float 0.0 and complex 3.14j. This is a complex value. So similarly 100 integer value, you can represent it in hexadecimal also. This 0x represent hexadecimal, and this is float value, this is a complex value. These are all examples, different examples of this is hexadecimal format. So these are different examples of numbers. What numbers can have, how can we have different type of numbers in Python. Python strings. Strings in Python are identified as a contiguous set of characters enclosed in quotation marks. Python allows for either pair of single or double quotes to put these strings into. Subset of strings can be taken using the slice operator, that is square bracket. This square bracket is called slicing, and the starting character and ending character in between colon within square bracket, this is also slicing. With indexing starting with 0 at the beginning of the string and working their way from -1 at the end. The plus sign is the string concatenation operator which add two strings together, and asterisk is multiplication or repetition operator which will repeat the string as many times based on what is the string and how many times you want to repeat it. Now this is Python string example. I already gave you this python2.py. I demonstrated this example, hello world. So string, the first character, third to fifth, third onward, multiplied by twice, that means repeat, string plus test. So these are this is the example I demonstrated, and this was the output of the program. Concatenation. So this is the output. Hello, yeah, this is the output. Hello world along with the test, because hello world is stored into string, right? So hello world is here plus test. This is test is written here. So this is concatenation operator. Means adding two strings together, combining two strings together, A, B, so together. All right. So you can have both string constants, or you can have one variable, one constant, or you can have both the strings, as per your wish. Plus is indicating that operator that which concatenate two strings. So here we are taking variables and a string together and concatenating them. So string and test, string and test together. A very powerful and useful feature which will be definitely used everywhere. Concatenation is very common operator used. Python list. List contains items separated by commas and enclosed within square bracket. The values stored in the list can be accessed using slice operator, that is same slice, with indexes starting at 0 in the beginning of the list and working their ways to -1 the end. Plus operator is a list concatenation operator, the way it is used in strings, and asterisk is a repetition operator. This also I demonstrated. Python 3. Now this is the list. First element index number 0, second element index number 1, third element index number 2, 3 and 4. So that means list 0 will have this, list 1 will have this, list 2 will have 2.23, list 3 will have John, list 4 will have 70.2. This is another list with 2 elements. Print list, it will print all the elements, means entire list. Print list 0 means will print only A, B, C, D. List 1:3, that means second, third and fourth, because counter start from 0. So this will be printed, and up to this all these elements will be printed. List 2: starting point, so from third point onward. Oh sorry, 1 means this one, yeah, correct, from here, starting from here. So list 2: that means starting from here till the end all elements will be printed. Then print tiny list multiplied by 2. This was slightly different. 1, 2, 3, that means from here to here these 3 elements will be printed, and this 2 onward, that means these elements will be printed. Tiny list multiplied by 2, that means 1, 2, 3 John, 1, 2, 3 John will be printed twice. List plus tiny list, all these elements along with the second element, list of second list. So all these elements plus these elements will be printed. Both the list will be concatenated. So this is the output. First, second, third, fourth, fifth, and this is the second list together. That is 1, 2, 3 plus John. 123 plus John, concatenated with 72.2 onward. So the first element of first list plus element of second list together. So we concatenated two lists together with plus sign. That is the Python lists. Tuples. Very interesting data type, not there in any other language, like C language or Java or C++. We don't have something called tuples. Tuples is a unique feature. It's a sequence of data type that is similar to the list. Then what is the difference? A tuple consists of number of values separated by comma. Tuples are enclosed with parentheses. That means this. So instead of square bracket, we put them into parentheses. The main difference between list and tuples are lists are enclosed in square bracket and their elements and size can be changed, while tuples are enclosed in parentheses and cannot be updated. That means you cannot update them. They are immutable. They cannot be updated. You cannot change their value. Tuples can be thought of as a read-only lists. The list elements which cannot be updated, which cannot be changed. So tuples means a kind of constant similar to list which cannot be updated. This is example number 4, Python 4, and example of tuples. Tuple ABCD 786 is same, but putting them into parentheses. That's the only difference. And tiny tuple. So we are printing same. Now onward the process is same, except that they are not updatable. Operators are same. Element number 0, 1 to 3, 2 onward, printing it twice. And concatenated list or concatenated tuples. That's what they cannot be updated. You cannot assign a new value to element number. You cannot change the elements. In list we can change them. These values make it read only. So that's the only difference. Tuples are read only variables. Lists are updatable. Their values can be changed. Their elements can be updated. You can replace a value. For example, in list, had it been a list, you could have replaced it 2.23 with 7.5. Allowed. The rest all the elements will remain the same. 786 could have been replaced with 2000. List, had it been a list, it would have been possible. But in tuple, not allowed. You cannot change the value. Alright. For example, weekdays. You cannot change weekdays. So you will prefer weekdays as a tuple. Days of month you will prefer because you cannot update them. They will remain fixed. But salary of a person, 5 salaries, you can update them, right? So whenever you feel like that the values will remain fixed, they are not updatable, you put them into tuple. Got it? Absolute values, fixed values. Yeah. So ABCD 786, the same element, output is same. Following is invalid with a tuple because we are attempting to update a tuple which is not allowed to confirm the same value. So this is tuple and this is list. Tuple 2 equal to 1000, not allowed. Invalid syntax with tuple, whereas in list it is allowed, valid. You got my point? So when you run this program, it will throw an error. Python dictionary are a kind of hash table types. Key value pair. You have key, you have value, and that's called dictionary. That's how the dictionary actually are. They are identified by some words and the description thereof, right? So if you have, for example, name is this, age is this, salary, phone number, you take records, that becomes a dictionary. They work like associative arrays or hashes found in Perl and consist of key value pairs. A dictionary key can be almost any Python type, but are usually numbers or strings, usually. Does not mean it is a rule, but usually we keep them in numbers or strings. Values, on the other hand, can be any arbitrary Python object. Dictionaries are enclosed by curly braces. So square bracket is for list, parenthesis is for tuple, and curly braces is for dictionary. Remember that. And the values can be assigned and accessed using square brackets. Now this is example of a Python dictionary. Python 5.py in your program. This is the same code. All the programs are verified and working, and the output is taken for your reference. I demonstrated a few examples, and rest now I can explain, because I hope you will believe that yes, output is genuine, because I'll give the screenshot of the output. So this is a dictionary, assigning a dictionary. And how you are assigning the value? Dictionary, index value, and the index and the value. So this is the element 1, this is the value 1 assigned to index 1 of this variable with the name dict. Second element, this is 2, and any dictionary name John, code 763534, department sales. So this is the key. Take note of that. These are the keys, and these are the values. Value, value, value. So key value pair. Take note of that when you are putting them into curly braces and you want to assign all the values in one line. You have to separate the value by comma. Key value pair separated by comma. Key value pair separated by comma. The 3 elements in the dictionary, and all the entire list, entire dictionary is enclosed in curly braces. That's what the dictionaries are. So print dictionary 1, so it will print this is 1. This is the value for one key, because you are passing 1 as a key. Print dictionary 2, that means it will print element number 2, that is this is 2, this will be printed. Print tiny dictionary, so it will print all the dictionary elements, complete dictionary. Print tiny dictionary dot keys, only the keys will be printed. Meaning is simple. Tiny dictionary dot keys, so you will get name, code, and department, all the keys. Tiny dictionary dot values, it will print only the values, John 6734 and sales, only the values will be printed. So we have separate function for keys, for values, and individual elements in the dictionary. And this is the output. This is 1, this is 2, and this is the complete dictionary, and this is dictionary keys only and dictionary values only. Data type conversions. Sometimes you may need to perform conversion between the built-in types. Naturally, like double quote 9 written in double quotes, and you want to treat this 9 as number, because remember that if it put in double quote, this will be string. If you want to treat this as a number, you have to convert it. So this conversion is required. Sometimes to convert between types, you simply use the type name as a function. There are several built-in functions to perform conversion from one data type to another. These functions return a new object representing the converted value. Like you want a value float to be converted to integer, or integer to be represented as a float, or string to be represented as number, because of the value returned by some function, some expression is in the form of string or in the form of number, and you want to change that into a different data type. So these are data type conversion functions. Integer. This function will convert to integer. This is x. Optionally, you can specify base also. Like whatever the value of x is. Suppose x has got 9 value and you want to convert it into 9 to the base 2, or that is base, for example, binary has a base of 2, octal has a base of 2, so, and the decimal number has a base of 10. So octal has a base of 8 and hexadecimal has a base of 16. So base 2 raised to power 16. So convert x to an integer. Base specify the base if x is a string. Long x, it will convert x into long, that is float value, I mean long integer. Difference between integer and long integer is the size actually. That you have not asked this question, but that is the only question answer difference. Like if integer is using, just for the sake of example, I am taking 2 bytes. That means 16 bits, right? This is the first byte, this is the second byte. So if you have total 16 bits and 1 bit is reserved for sign, so we got 15 bits to represent the number, and 2 raised to the power 15 comes out to be 32,767. That is the maximum value you can have in integer, assuming that it is using 2 bytes. So if you use 4 bytes, then the value will be multiplied again, because in that case you will have, if you are using 4 bytes, that means 32. So 2 raised to power 32 will be the answer. If you leave 1 bit for sign, it will be 2 raised to power 31. That will be the total number of possible combinations. This is how we calculate. So integer and long has simple difference, that whatever number of bytes integer is using, long will have double of it, twice of it. Float is decimal numbers, convert x to floating point number. Complex, real value and imaginary value, create a complex number from the given values. String x, convert object x to string representation, that is REPR, convert to expression string, x into expression. And then evaluate, very good function actually, evaluate a string and return an object. That is, for example, you have an expression 2 multiplied by 3 divided by 4, so that become an expression. So you want to evaluate that, you want to calculate the value and you want to find out that. So a string, for example, if I say 2 multiplied by 2 and divided by 4 plus 5, and I put that into double quote, so this become expression. If I want to find out the value of this expression, I can use eval. Similarly, tuple, convert s to a tuple in the form of dictionary. Now remember that values must adhere to the data type being converted. That's your responsibility. Python will throw an error if they are not convertible. Like the s example, this must have the value which can be represented in the form of tuple. So these are data type conversion functions in Python, very important because we will be needing it. Right now we are just understanding the basics. More functions, list, it will convert s to list. Set, it will convert it to set. Dictionary, create a dictionary. D must be a sequence of key value pairs, key value tuples. Frozen set, converts to a frozen set. Char, convert integer to a character. Unichar to Unicode character. ORD into an integer value. Convert a single character to its integer value, which means like uppercase A is 65. So convert that to 65. That is value. Hex, convert an integer to hexadecimal value. Octal x, convert an integer to an octal string. So these are possible conversion functions, day-to-day use functions we use in Python, and definitely you will find very interesting use of these functions in your daily life. Operators in Python. We have a dedicated session on operators and mathematics, so we are just looking at the overview of it. Let's understand a simple expression, 7 plus 4 equals to 11. Very basic I am discussing right now. Here 7 and 4 are called operands. and plus is called an operator. Python language supports these operators: arithmetic, comparisons like relational, assignment where you assign the values, logical which results into true or false, and bitwise which perform operations on bitwise in your number, like these are bits for and you have two numbers and you want to perform some operation, bitwise operation on these numbers. Suppose these are the numbers. Now what operation you want to perform bitwise means from between this bit and this bit, between this bit and this bit, and individually what all possible operations are allowed bitwise. We have bitwise operators also. And then membership operators to check whether this is a member of a given list or given tuple or given dictionary. That is finding out whether a given value is a member of a given group or not. And then identity. We need to understand all of these operators in detail, and we have a session on this, don't worry. But summary is this: self-explanatory. Plus a plus will give you 60, minus subtraction a minus b give you 40. In this case, if you say b is 50, a is 10, then you can expect a minus b will be minus 40. Remember, don't get confused, please. Multiply will be multiplication, that is 10 into 50, 500. Similarly, division, b divided by a will give you 5. This is remainder operator. B divided by b percent a will give you what is the remainder. If you divide 50 by 10, the remainder will be 0. Then this is exponent. So a raised to the power b means 10 raised to the power 50. 10 raised to the power 50 will 10 to the power 50 is what? You can calculate that. And this is floor division, the division of operand where the result is quotient in which the digit after the decimal points are removed. Means ignoring the decimal part, only the whole number part of the division will be taken. For example, 9 divided by 2, floor division will be 4. 9.0 divided by 2.0 will be equal to 4.0. Decimal part will be completely ignored. However, if you take single slash, it will be 4.5. Then we have comparison operators. So equal to means if both are equal. In this case, a and a equals to b, not true. Not equal to, yes, it is true in this case. This is not allowed, this is not equal. Earlier it was there, but no more available. I noticed that. I just checked. This was error, returning error in Python. Greater than, less than equal to, greater than equal to, less than equal to. Self-explanatory from your basic mathematics school. Then assignment operators, equals to, assign, like C equals to A plus B. So A and B will be added, will be assigned, the value will be assigned to variable C. Plus equal to, that's very interesting. You may not have seen this operator. This is basically, if I say C plus equal to A, this is same as C equal to C plus A. Like if I say A plus equal to B, if I say A plus equal to B, that actually means A equal to A plus B, A equal to A plus B. So what will happen, what will be the value of this here, A equal to A plus B? So the value of A will be 10 plus 50, that will be 60. So this is very interesting. Similarly, minus, A equal to A minus B, multiply equal to, similarly divide equal to. So all these are allowed. These are very interesting operators. Same, this is directly taken from C language, C++ language. We use these in C++. Similarly, as I said, divide equal to, remainder operator, that is modulus operator, then raised to the power, and then floor division. Same operators, same syntax. Like C divide equal to A is same as C equal to C divided by A. C percent equals A is equal to C is equal to C percent A. So therefore this is raised to the power this exponent and operator. Like if you say C exponent A is equivalent to C is equal to C raised to the power A. So this is a very interesting operators in Python language which are frequently used. Bitwise operators. Bitwise operator works on bits and perform bit by bit operation. Assume that A is 60. Let's convert A 60 into bit first. And the formula is quite simple. Keep on dividing by 2. 2 30 ja 60, remainder 0. 2 15 ja 30, remainder 0. 2 7 ja 14, remainder 1. 2 3 ja 6, remainder 1. 2 1 ja 2, remainder 1, and 2 ja 0, remainder 1. So this is the representation right in reverse order. So 60 is 1 1 1 1 and 0 0. This is 60. This is how you convert a decimal number into binary. And B is 13. So this is the first one. If you write all the number additional 2 more digits you are writing, that does not make any sense to me. However, if you are writing that, because you are actually adding total counting how many digits are there. So you are counting 8 because you are completing the byte at least. So you are adding leading zeros to complete 4 bits. 8 bits, which makes 1 byte. But our answer was up to here. So we added leading 0. This is 60. Similarly, this is 13. Now if I say A ampersand B, that means AND will be applied between these bits. 0 and 0. AND will operator return true if both are true. 0 means false, 1 means true. So 1 is true, 0 is false. So if both the digits are 1, then only it will return 1, otherwise it will return 0. So this is 0, this is 0, this is 0, this is 0, but in this case both are 1, so it will be 1. Then in this case both are 1, so it will be 1, and rest all 0. So this is bitwise AND. Similarly, bitwise OR. Bitwise OR means either of the two has to be 1. So this will be 1, this will be 1, this will be 1, this will be 1, and this will be 1. So that is bitwise. So these are 1 and last one is also 1. This caret symbol, this is exclusive XOR. We call it as XOR. Both has to be, if both are same, then that will be bitwise exclusive OR. So one second. Right. Logical operators. There are following logical operators supported in Python language. Assume variables hold 10 and the variable B holds 20. So AND, meaning logical AND. If both operands are true, then the condition becomes true. So A and B will be true. OR, called logical operator OR. If any of the two operands are true, that is non-zero, because 0 means false and non-zero means true. So in this case we are getting true. Not negation. So negation means if it is true, return false. If it is false, return 0. Like not of A and B will be false because both are true. So the answer not of true, negation of true is false. These are new operators. I'm sure you have not heard of these operators, but these are interesting, and Python is incomplete without these operators. Membership operators. Membership operator test for membership in a sequence like strings, list or tuples. In, meaning it is a member. Not in, meaning not a member. This is example of membership. Python 6.py. So we will see A equal to 10, B equal to 20, and the list is 1, 2, 3, 4, 5. Now this is a simple if, though I have not talked about the conditional constructs, if statements, but then for the sake of understanding, I think it is easy to understand. And this also represents that suite which I was talking about, because colon represents suite. If A in list, then A is available in the given list. In this case, since it is not there, so you'll get the answer of else. Else A is not available in the given list. So this is my first example. Second, if B is not in the list, B is 20, even B is not there, so I'll get the answer B is not available. Oh, sorry, not in. B is not in list. Yeah, it is not in the list. So you will get this answer. B is not available in the given list. Similarly, A equal to 2. Now you try again. A in the list? Yes, in the list. So A is available in the list. Similarly, print A is not available in the list. So when you execute this, you can easily guess the output now. This is output. A is not in the list. B is not available in the list, and A is available in the given list after you change the value of A here. Identity operators in Python. Identity operators compare memory locations of two objects. Do we have the same value at the memory location? So that's the identity operators. For example, is will tell you X is Y. Here the result is 1 if id of X equal to id of Y. Means they are both at the same address. Not, meaning they are not. So the example will clear it. That identity operator. This is Python 7 example in your source code. A equals to 20. B equals to 20. If A is B, meaning we are trying to understand, are they sharing the same memory location? Because they are same values. So Python is very intelligent, and they will assign the same memory area, and we'll call them as the same space will be given, and that is the reason answer will be the first line. A and B have same identity, and this is the output. If id of A equal to id of B, so and this is the output, you will get A and B have same identity, because this is true. Actually, indeed, this is true. Else this will never be executed. You will not find this line. B equal to 30. Now you are assigning another value. So therefore, when you assign a new value to a variable, it will be given another memory location. Now the ID will change. So therefore, line number 3 and 4, which are coming up in the next example, this will be executed. Line 3, A and B do not have same identity. A and B do not have same identity. And the last, line 4, do not have same identity, because we are typing A is not B. So that's the example of identity operators in Python. So that's operator precedence. If you have an expression which consists of all these operators what we have learned, what is the precedence? Which one will be executed first? Which will be solved first? In normal mathematics also we have bod mass, or we have braces and unary operator first. So we have parentheses are resolved first. So similarly in Python also have some precedence. All operators from highest precedence to lowest. Star will given the highest priority, double star, that is exponential, will be resolved first, will be solved first. Then unary operators. These are all unary, complement, plus and minus, unary plus, unary minus. Unary means using single value, like minus of A, that is unary, plus 5, that is unary. Unary means needing single operand. So plus and minus can be used as unary operators also, meaning single operand. They can be used with single operand also. Then plus minus, that is addition and subtraction. Of course, after that in between we have this multiply, divide, modulo and floor, then plus and minus, then right and left shift bitwise operators, then bitwise and, then bitwise exclusive or and regular or, then we have comparison operators, then we have equality operators, then we have, this is not equality operator, now I verified it's not working. Then we have assignment operators, then is not and, not or and. This is the highest precedence. So if you have all these operators in an expression, first this will be resolved, then this will be resolved, then 3, 4. This is the priority how they will be solved first in Python. That's all for this session. I'm sure you enjoyed it. Thank you.